Okay guys, today I'm going to tell you about ocean currents. So for the sake of time, I showed you a bunch right now. Most importantly, you got to remember that ocean currents travel a similar route of global wind patterns, okay? And they change the climate of land masses all over the planet. Now this is because water, because it's more dense than air or gas, it has a tendency to hold on to heat much better, okay? So warm water coming from the equatorial regions can actually heat northern regions of the planet on the land masses themselves, and the vice versa can happen in the south. Most importantly, you got to remember about ocean currents. Okay, they travel in a clockwise motion because of the Coriolis effect, of course. So that's going to bend objects to the right. Okay, so everything's going to turn right everywhere in the northern hemisphere, and everything's going to turn left in the southern hemisphere. So you can see you have something called the north equatorial current, bringing warm air in the North Pacific up into Japan. This is the Kuroshio current. Okay, warm air is heating the climate of China and Japan and Korea. Okay, and then polar cold air from Alaska is coming down and cooling the California coast. The water on the California coast is quite cold for this reason, okay, because it's bringing cold water and then thus cooling the climate, okay. This is actually what contributes largely to the climate of San Francisco. Likewise, you can see the north equatorial current in the Atlantic Ocean connecting to the Gulf Stream, okay, heating the northeast United States and particularly Europe. Okay, Europe would be a very cold climate if it wasn't for the Gulf Stream. This is bringing warm Caribbean water, heating the climate of Ireland and England and France and Denmark. Okay, and then you have polar cold currents coming from the polar regions, coming down towards the Horn of Africa. Okay, same thing in the south. You have south equatorial warm currents coming down, the Brazil current, and then looping back around. But you'll notice it's very different over here. This is a counterclockwise current, whereas up here it's clockwise, bending to the right, bending to the left. Okay, so let's pick up in the southeast Pacific. Okay, we have something called the south equatorial, just like we have over here. South equatorial current. Bringing warm air from the equator down towards, if you guys have ever seen Finding Nemo, down towards Australia. If you remember the character Crush, that's how Dory and Nemo get back to Sydney. They rode the East Australian current right back to Australia. Okay. Now, once we get back towards South America, it's going to be cold again. This is bringing cold air, cold water back up towards the equator. This is the Peru current. Now let's look at the other side of the world. Warm equatorial air coming down the west coast of Africa. I'm sorry, the east coast of Africa. This is the Mozambique current. It's warm, okay? Just like on the other side of the world, we have the south equatorial. And then on the other side of Australia, we have the west Australian current, counterclockwise. So likewise, this is counterclockwise. Everything up here is going to be clockwise. Okay. So as you could see in the last diagram, on the other side, this is the Kuroshio current. This warms the climate of Japan. Warms the climate of Japan right here. Kuroshio current. And that's going to go back up here. And then going back towards the California current, bringing cold air down the coast of California. Okay? So this is a global phenomenon. Counterclockwise, clockwise. There are many more currents other than this, but these are the most well-known ones. Counterclockwise, counterclockwise, clockwise, clockwise. If you ever look at the best way to understand this is look at the climate of Ireland and England. They're really high north latitudes, okay? And they have a relatively seasonal climate because of the Gulf Stream current that brings very warm currents from the Caribbean and heats these regions. It literally changes the climate. Okay, this is Ocean Currents, guys. Thanks.